In this video, we're going to look at balancing chemical equations, how to do them, and why we do them. Firstly, what is a chemical equation? Well, it describes a chemical change. So when we're looking at a chemical equation, we have a couple of things. On our left side, we have reactants. On our right side, we have products. And in the middle, we have an arrow. Let's take a look at a few numbers that are going to appear within our balanced chemical equations. First one is going to be a subscript, which shows how many atoms we have present. So for instance, we have a 2 here for the subscript. This means there's 2 hydrogens. There is not a subscript here with the oxygen. However, there's an understood 1 that happens to be there. Now, a coefficient is a number that's going to go in front of our chemicals. So what this 3 means is that we have 3 water molecules present. In terms of individual atoms, we've got 3 times 2, which gives us 6 hydrogens, and 3 times 1, which gives us 3 oxygens. Here's a little animation showing the synthesis of water. You can see the green molecules are hydrogen, and the red molecule is oxygen. Law of conservation of mass. So this is the actual reason that we have to balance chemical equation, because we're never creating atoms, we're just rearranging them. So here is an unbalanced chemical equation. If you take a quick look here, we have the red molecule here, hydrogen, stands out. We've got 2 on the left side and we have 3 on the right side. So there needs to be some balancing. So if I was going to balance this chemical equation, the first thing I would look at would be the carbons. We have 1 on either side, so I'd be happy with that. Next, I'd move to the hydrogen, where we have 2 hydrogens here and we have 4 hydrogens on the left and 2 on the right. So we need to put a 2 in front. So that's going to double that. In terms of oxygens now, you have to count them all up. We've got 2 oxygens here with the water. We have another 2 here. So that makes 4. So in fact, what we need is we need a 2 in front of this oxygen, because that will give us 4 in total. And there you can see it now. So visually you can see how we've doubled our oxygens and we've doubled our water molecules. And if you count up all the atoms, they should all be balanced. So a couple of rules, a couple of tips. Subscripts, we only make those when we're making a balanced chemical equation. If we're going to try to balance, we need to add a coefficient. And remember, coefficients always go in front of things and never in the middle of a formula. So a few tips here. The only problem with a few tips is that we can't exactly carve these tips in stone. There's no way, there's no system that I can say do this, do this, do this, and every time it'll always work. So a couple of key ones would be, the second tip here is a polyatomic ion like a nitrate, which would be an NO3. Sometimes you have NO3s and maybe there's a little 2 outside. So I would treat that as 2 nitrates, not breaking it up into the individual atoms, like 6 oxygens or 2 nitrogens. Look at it as being 2 nitrates. So let's take a look at a few examples here. So we've got nitrogen and hydrogen. In terms of numbers here, we've got 2 nitrogens, 2 hydrogens for our reactants. So that would be our left side. And on our right side here, we have 1 and 3. So we've got clearly we need to do some balancing. So probably the first thing I would do would be to balance the nitrogens. If I have 2 on the left and I only have 1 here on the right, I'm going to put a big 2 in front. Now there we go. So what that is going to do is that it's going to give me 2 nitrogens. It's also going to give me 2 times 3. It's going to give me 6 hydrogens. So almost done here, because now I have 6 hydrogens. If I look back on the left side, I only have 2. So what number times 2 is going to give me 6? And that will be 3. And there's a visual. So here's another one. Again, we've got a few reactants. We've got potassium, chlorine, and oxygen. So there's all our numbers. Again, when you go to balance something, just find one atom that isn't balanced. Our potassiums and our chlorines actually start as balanced, and our oxygens are not. If you've got an even number like 2 and an odd number, it's almost like treating it like a fraction. So 2 times 3 would be 6. So what we want to do is we want to get 6 oxygens on either side. And so if we put a 3 here, that gives us 6 oxygens, and putting a 2 in front here gives us 6 oxygens. Now, that does actually throw some of our balancing off that we already had done, because the potassiums were actually balanced. But if you look, now we actually have 2 potassiums. So we're going to have to put a 2 here. And that should probably also balance our chlorines out. And there we go.